Terrific. Well, welcome everybody. I'm thrilled to join you for one in our series of IGS workshops. Today, we're going to focus on Jupyter Notebooks and how to use them in Pro. And the way we do these workshops is we have a little presentation at the beginning that sort of introduces all of us and we learn a little bit about you. And then we set the stage technologically, sort of the background, and then we launch into the hands-on workshop. So that's going to be what we're going to do today. And the first thing I like to do is introduce you to our program. And some of you have been doing our workshops, so you know this, but and that's the ArcGIS program, we are a program under the University of California Division of Agriculture and Natural Resources, and UCANR, as you probably know, is devoted to connecting the power of UC research with local communities to improve the lives of all Californians. And we really do believe in this. We're a service entity. We are a network of people across all of the counties of California, in research and extension centers, and at affiliated UC campuses. And we do a lot of great work around agriculture, natural resources, nutrition, and youth development. And one of the ways that we do this programming is through statewide programs. And some of them you might be familiar with: 4-H, California Naturalist, Master Gardener Program, CalFresh, the Integrated Pest Management Program, for example. We are also one of those statewide programs. We are the Informatics and GIS program, and our goal and, really our mission and our love is helping you integrate cutting-edge geospatial tools into your work. And we do this through training like today. We do it through a service center where we can help you complete projects. We do it through research projects, and we fly a lot of drones. So we're a bunch of mapping nerds who love to help out. So that's what we are, and this is who we are. You're going to hear mostly today from myself. I'm Maggie Kelly. I'm the director of the program, and you're going to hear from Shane Fire. He is our GIS program manager, and he's just an absolute expert in all things Jupyter Notebooks, ArcGIS Pro, and the integration of those two. But behind the scenes, we've got Sean Hogan, Robert Johnson, Ben Satzman, and Andy Lyons. And so if any point something's not working, or you're having trouble, or something doesn't look right, you can either interrupt us, or you can just get in the chat and go, this isn't working, and one of these guys will jump on to help you. So we are here to make this a rewarding experience for you. And now who you are. So we always make a map of the registrants, and we understand some folks, register and don't show up on the day, but we've got a great worldwide distribution of registrants today. It's really fun to see a lot of you from Northern California, but then a lot of you from all over the world. And so to help us understand a little bit more about you, if you would be so kind, if you could put in the chat your name. If you want to, you can put what you want to hope to learn from this workshop, but definitely put your experience with Python or Jupyter Notebooks, 1 being beginner and 5 being expert. So let's get that chat thread going. If anyone wants to jump in and start, I would love to see that. Who's going to be the brave one? Yay, Athena. Lovely. 1 beginner. Perfect. Shane. Great. Hey, AJ. I met with AJ this week in office hours. I'm glad you're here. Anybody else? Love it. Awesome. Hey, Jesse. Jesse's got some very interesting projects going on, I know. Ben, great. All right, I'm going to close my chat. You guys keep that thread going. I'm going to keep on with my presentation. All right, so you know why you're here, but let's just sort of review why you might want to be here. So the goal of our workshop today is to introduce you to using Python and notebooks within ArcGIS Pro and get started on basic scripting in Pro. And the reason you might want to do this is because you've been doing the same task over and over again using the GUI, and you want to learn to automate that. And you want to learn to do, quick and repetitive tasks in an automated fashion, and that's scripting. You might also want to work faster and protect your wrist from endless mousing or trackpad actions. You might want to learn to connect to external data sets via APIs. You might want to send code to a colleague so you can better collaborate. And you want to work in a scripting environment to ensure reproducibility. So all of these might be, a few of these might be your goals. And so if that's the case, you're in the right place. And so we're going to talk a lot about these notebooks or Jupyter Notebooks. And so just a little background, what is this thing, Jupyter? Why is it spelled so weird? And it's spelled so weird because it's a loose acronym that unites three programming languages: Julia, Python, and R. It supports now other languages, but that's the reason behind this weird spelling. And Fernando Perez there on the left, he's a statistics professor at Berkeley, all around super guy. He's part of the Data Science for the Environment and the Institute for Data Science. He's sort of the lead behind Jupyter Notebooks. And since their development, they've been employed in all sorts of settings, and ArcGIS Pro is just one of them. So what they do is they support analysis, collaboration, and reproducibility. And what they are, they're web-based, open and interactive computing platforms. They're basically windows that allow users to combine live code, equations, text, all sorts of stuff in these windows. And these, as you'll see, these notebooks really enable the collaboration, and they create these reproducible computational narratives that can be exchanged and used across audiences and platforms. They're really very flexible and a terrific way to learn coding and to do GIS work. And so when we talk about notebooks in Esri software, we can look at this picture here. On the bottom, we've got the Esri suite, the local, which is ArcGIS Pro. We're going to be working with that. We also have, if you have an Esri license, you have access to ArcGIS Online. That's the cloud-based platform. And those two are becoming increasingly parallel. It used to be ArcGIS Online. You couldn't do as much, but that's really changing. But these kind of notebooks are ways to bridge out of the Esri world. So in our case, we're using these notebooks to grab data from something called CalAdapt, and we're going to be analyzing that. There are other ways to, bridge out of the Esri world. One of them is called the R bridge. This goes directly to R, and there's also a ArcGIS API for Python that goes directly to Python. But we're really focusing on this new concept of notebooks because that you can do all of that and more. So what we're going to do today, we've done the introductions. I've talked to you a little bit about what notebooks are and the basics about Esri. We're going to do a little bit of some definitions. We're going to show you a few examples, and then we're going to get into the heart of the matter, which is the workshop. And this is where Shane is going to go through Python basics and exploring how ArcGIS user interface works. We're going to touch on using the history function in Pro, which is amazing. You're going to open and use a Jupyter notebook. And there's also an example, if we get that far, to look at spatial data with a third-party Python package. And then we're going to interact with CalAdapt. So what is CalAdapt? Maybe some of you don't know. The CalAdapt API is a website. It's your portal to California climate data. This is a state-funded project that allows you to explore peer-reviewed data about California's changing climate across many, many factors: rainfall, temperature, fire, snowpack, flooding, all this sorts of information. All of the data is available through downloads, through visualizations, through very cool tools. And they also have this fantastic API that we're going to use notebooks to reach out and grab data from. Another snapshot about CalAdapt, just to, if you're if you don't know it, I encourage you to check it out even outside of this workshop, but it makes climate data easily accessible. There's tons of cool maps, great charts. You can zoom in on your area. You can do downloads, all sorts of extremely gorgeous visualizations. It's a really great site to check out. All right, so we've talked a little bit about how Jupyter Notebooks do all these amazing things. We should also, touch on things that maybe they don't do well. And there are some things in GIS, I think, that you really can't script. For example, sometimes you gotta put mouse to image and do some manual digitization, and that's kind of hard to script. I mean, there's lots of ways to do it, but sometimes you really do just have to do it yourself, and that's tough to do in a notebook. There are some fine tunings of design and cartography that maybe are harder to script, but I have a question mark there because I think there might be two schools of thought on that. Sometimes scripting or coding has a steep learning curve, and sometimes these languages can seem intimidating or confusing. And that's what we're doing here. We're trying to get you over that initial hump. A lot of you already are over that hump, but one way to get over that hump is just to think about this scripting or coding. It's just a recipe. It's scripting in any programming language is just thought as working through a recipe in your kitchen. You've got some ingredients, you've got a set of instructions, and you've got to step through those. And in a GIS world, we're talking about, what are these workflows that I do repeatedly, or that I need to cascade, or I need to pull together to have a more thorough workflow. All of that is going to be better done with scripting. And of course, it'll help you collaborate and reproduce your work. So Shane's going to get into this with a hands-on, but I just wanted to introduce this a little bit because a few of you are Python newbies. So it's a free cross-platform open source scripting language. It's very powerful and it's easy to learn. Some definitions here: a module is a file containing Python code, and a Python package is a directory that holds a lot of those modules together, or those scripts together. We're also going to talk about package managers, and this is a software bundle that installs Python and associated packages. And then we're going to mention Python environments, and that's in the Esri world. This is what we're going to be working with. It's a full installation of Python with all these associated packages. And in the Esri world, right now it's called ArcGIS Pro-Py3 environment. So a little more background. Most of us interact with ArcGIS Pro via GUI, via either, with an external mouse or a trackpad. So you're directly manipulating the graphic icons such as buttons or scroll bars. You're kind of in there pushing the mouse to do the work for you. That's how a lot of us interact with Pro. But you can also interact with Pro via Python. And here you can do this directly from the ArcGIS Pro ribbon, finding that Python icon and actually script directly in Python. And so this is going to pull from that Python environment, ArcGIS Pro-Py3 that I mentioned before, that has all these Python packages that you're going to need, as well as other packages like SciPy and Pandas. And you can do all of that via that little Python button on the ribbon. You can also interact with Python via notebooks, and that's what we're going to be doing today. And so the notebooks come pre-baked with a lot of very popular Python packages. So all of the standard stuff that you need is going to be pre-baked into these notebooks. You can also add more. If there's a particular package that you love or you've used before, you can go out and grab that. There's a little bit of fussiness that has to happen that Shane will talk about, but you really can have all of the Python tools that you're accustomed to or that you learn about or that you need, you can bring them to use in your ArcGIS Pro instance. You can also code or script in Python outside of Pro, right? You don't have to rely on Pro. And so when you have ArcGIS installed on your computer, you can use Python command line or idle or anything else, even these notebooks, without even opening up Pro. So in summary, you can be working with Python within ArcGIS Pro through the Python window or through notebooks. You could also access Python outside of Pro, but we're going to, and Shane's going to talk more about these. So what do notebooks look like in Pro? This is sort of a typical Pro window. It's got the ribbon across the top with all of these great tools. It's got table of contents on the left, and it's got catalog on the right. And if you haven't done Pro yet, don't worry, we're going to get to this. And what Pythons just look like is, instead of that map there that I had in the previous picture, you can open up your notebook, and it's just these windows, these cells that have a bunch of Python language that basically are doing those steps, like I said before, to make this cake or souffle or whatever it is that you want to make. So it's pretty great. Shane's going to go over this, but one of the best ways to start to incorporate Python into your GIS processing is to get used to checking your history pane. And so that's typically, I like to have it on the right-hand side. It tracks all the processes you've completed along with warnings and where everything is situated. And so, in my case, I've got clip, add fields, create feature, create file geodatabase. Each of those I can right click on and find out what I did. I can rerun it, and even more cool, I can take that and just turn it into Python code. So you're going to get used to doing that in the workshop.
If I can add one thing to that, Maggie, you made the comparison to a recipe. If you've ever been a baker or a chef and you make a recipe and it's amazing, but you made changes, you don't know what those changes are. But in ArcGIS Pro, there's this history panel which allows you to know what those changes would be if it was an analogy of a recipe. So you can actually get at that information just by using that. Yeah,
it's so great. It's so rich. Sooner you get used to your using your history pane. Sometimes I'm like, what the heck did I do? So anyway, it's really great. We've been talking about Pro up to this point, but you can run notebooks in the cloud-based GIS in ArcGIS Online. And so Esri recently, last year, included notebooks within ArcGIS Online. It's super great, which is why I have 2 exclamation points on this slide to show off my enthusiasm. So that you can easily write and share your notebooks within ArcGIS Online. So we're not going to get in touch on this a lot, but it just goes to show that these kind of notebooks are really going to be throughout GIS, and they're a fundamental part of your GIS future for those of you who are, thinking about jobs, etc. One caveat is it's a little bit easier to install your own third-party Python packages in ArcGIS Pro. In ArcGIS Online, they don't really encourage that. But this is what they look like in ArcGIS Online. If you've ever looked at it, there's just, it used to just say home, gallery, map, scene, groups, content, organization. And now they have this tab, which is notebooks. But we're not going to talk much about that in this. We're going to focus on Pro. And I'm going to close here. I just want to thank you for joining us. If you want more information about our crew, or if you want to follow us on, how you can learn more, our website is here. We have got a suite of trainings coming up. We do some really fun stuff. If you're into this CalAdapt stuff, we delve deeper into it later. We also do work using field maps. So taking your smartphone out in the field to map using an app. We do a workshop on story maps, and we do a focus story workshop on ArcGIS Online and Google Earth Engine. So on to the workshop. We're going to take breaks throughout this. During the break, if there's any updates, we're going to email you, but we're also going to keep you posted in chats. If you're having trouble with anything, just reach out in the chat. We got a lot of folks here to help you. So Shane, what is your pleasure? Do you want me to turn the slides off, or do you want to focus on those remaining slides?
I can quickly do those remaining slides, but I've got it ready on my side, so
Great.
we can
So I'll
just switch
stop.
sharing screen.
Yeah.
Yes.
Great. Thank you.
And Maggie, quick process question. Before we really get into the workshop, do we want to do a break, or do we just want to move right into it?
It's up to you. You feel
Okay.
how you get the sense of, yeah, where we're at.
Understood. Understood. Okay, 1 second. So real quick, as Maggie mentioned, we're going to be going through this. We're going to go into how to access Python and Jupyter Notebooks installed by ArcGIS. This is going to be inside ArcGIS as well as outside. And there are some reasons you may want to work outside of ArcGIS. One thing I have noticed, I'm just going to mention this right now, is there are certain things that you will see examples. Let's say you're going through tutorials and they're walking you through Jupyter Notebooks. You're going to find things you cannot do in ArcGIS Notebooks. There's certain features that are disabled, but then what you do is you open Jupyter Notebooks that outside of ArcGIS, and you can always do those things. So just keep in mind, you may have to switch back and forth depending on what you're trying to do. And then really the goal of today is to get you using Jupyter Notebooks inside of ArcGIS Pro. So we're going to talk about automating workflows, performing geoprocessing tasks, creating summaries, and then working with CalAdapt climate data. Just as a quick analogy of how useful this is, a couple of years ago, I had to do a project where I needed to create a series of maps for a research project we were working on. There were like 200 maps. I scripted it, and working with this collaborative team, they kept asking for minor changes, which happens in a collaboration. And I was able to reproduce 200 plus maps within less than an hour, just because it was scripting out. I would change a variable, hit go, and just let it churn on the background, background. And it was really a powerful way of doing things, and really got me thinking about how to use Jupyter Notebooks better in research and data science. So I just wanted to highlight that. So what we're going to do today, after I go through where to locate Python and inside and outside of ArcGIS Pro, we're going to tackle 4 notebooks. The first one is going to be basics. I saw that one person mentioned that they would like to look into or learn more about using loops inside of ArcGIS Pro. We are going to hit in number 1, the basics of Python. Indentation, which sounds trivial, but in Python, it's important. Different types of variables, different types of data types, sequences and custom functions, conditional statements, iterative loops, and user input. So all things you're going to want to do when you're doing basic programming inside of Python. In the second workbook, we are going to start tackling geoprocessing and using tools from ArcGIS. We're going to bring data in from ArcGIS Online. We're going to analyze it in Pro, and then we're going to graph it, and even graph it using pandas. And so you can see how all that works. In notebook number 3, we're going to use a custom Python toolbox, which is written to pull data from the CalAdapt API at UC Berkeley. And you'll be able to bring back information, historical data, as well as future climate projections for given sites in California, and actually be able to graph those data and see what's going to happen. And then we're also going to use third-party packages of pandas once again, and matplotlib, just so you can really see how those different packages work and what you can do with them. And if we have time, there's an advanced notebook included. And this one really is meant to do advanced analysis. So this one, you're gonna go using the CalAdapt Py toolbox. You're gonna pull data, and that CDF data, back to your computer, which is a multidimensional raster. We won't go into that right now, but it pulls it down, and then you can do really elaborate analyses with your own data and the source climate data. And we walk you through some ways of doing that in number 4. We probably won't get to it today, but I've included it just so if you really want to push where things can go, you can work through number 4 and see how it works, and really get more ideas of how you can work with Python, multidimensional data, and climate data. It's really a cool little addition, in my opinion. One thing I want to point out in this presentation, some additional resources for Python. They're very helpful. They came out, I want to say, 2 years ago. but it's all about working with ArcGIS and Python and Jupyter Notebooks. These are put out by the Esri Press. They are really helpful. And then also, here are 5 tips that Esri recommends for getting started. And this is really good advice as you're developing code. And you'll see as you move through this, when you start working with Jupyter Notebooks, what it means. But don't put all your code in one cell. It becomes really hard to troubleshoot what's going on if you have errors, and it's hard to follow. I'll have to admit, in example number 4, script number 4, that the advanced workshop, I fell victim to putting too much in one cell, so don't hold it against me. Keep in mind there are different types of cells in Jupyter Notebooks. And there's a bunch of different things: executing cells, exploring interactive mapping options we don't do in here, but you can, and explore new modules. Try to figure out what's going on and how these things work. It's an open environment. People are always building new packages, new capabilities. So if you find yourself in a unique situation and you need to do something, I recommend first stepping back and searching online to see if anyone else has developed things for this, because they may already exist. So with that, let's get started in the workshop itself. So I'm going to switch my screen. Okay. So you all should have the exercise or the write-up, which is a outline of what we're going to talk about today. And in there, we spoke about, we write up the basics of what Maggie already talked about Python, how it's an open source platform, a programming language that we can download and use. Also that there's a broad community that's constantly developing new modules, new packages to use within Python, and it's available to everyone. It's a collaborative language where you can write a new module, share it with others, they can use it, improve upon it, share it back, it becomes collaborative. It's a really, really strong programming language, and it's really nice to work with. And it's one of the principal languages used these days in data science. So learning Python is very important. It's very helpful to get daily tasks done. So what we're going to do is we're going to work through this outline. I'm going to show you how to get access to these different tools, different ways of entering and using Python within ArcGIS, and then we'll move on to within ArcGIS Pro itself. So the first thing I want to show you is how do you get access to Python outside of Pro? So when you install Pro, automatically it installs a Python instance, and it's going to be Python 3.9, which is relatively the newest version. I think they're up to 3.10 or 3.11, but 3.9 is what it installs. It installs the command line, it installs an interactive development environment, and then installs Jupyter Notebooks. So if you wanted to actually go in and just use the basic Python interpreter and the shell, you just go to your window and you type in Python. This is within Windows. And I should note that ArcGIS Pro, it hasn't been said yet, but ArcGIS Pro is only available for Windows 64-bit operating systems. So you wouldn't be able to do this like we're talking about right now on a Mac, unless you had a Windows machine running inside of Fusion or Parallels or something like that. So I've gone in here and I've searched for Python. And what the first option that comes up is the Python command prompt. So if I click on that, it'll take a second or two, and the Python command prompt will show up. One thing you're going to see here is this right here, when it says ArcGIS Pro Pi 3. I've got NB. I created this environment. I cloned it. And that is the environment we're using. So it tells you what environment you're using. And right here, if I typed in Python, it'll open the Python interpreter, the Python shell, directly inside the command prompt. The Python command prompt. Right here, the 3 greater than signs is an indication that you are in the Python interpreter. So if I was to go in here right now, I could actually write some Python code. Nope, I'm going to get an error because I had 2 different types of identifiers for string. I had a single quote and a double quote. So I just said print Shane, it did it. So but the thing about Python, the Python shell, is you can go up and down. You can get your previous code that you've written, but it's one line at a time. And there's no way to save this out as a file for use later. So it's literally just for instantaneous coding and working on just doing some basic tasks. I don't use the Python command, the Python shell very often, but it is available. Something to note, if you get in this far, you get into the Python shell, you need to know how to get out of it beyond just killing the Python command prompt. So you just type in quit, open close parens, and it drops you out of Python and takes you back to the command prompt. If we want to have a little more control though, and we want to be able to create scripting files and be able to run them and save them, one thing you can do is you can run the program that ships with Python called idle, IDLE. So if I type IDLE in the command prompt, it is going to open up the idle command, the idle window. And this is going to be on page 3 of the exercise for today. And it opened it up in the background. You'll see this is the idle window. And once again, in here, if I wanted to, I could type in, just like I did earlier, I could type in my name and it'll print it. But here I can't go back up by just using the cursor. I have to retype the code. The way to get around that, and the nice thing about it is I come up here and I can say a new file. And it's going to open a window and it creates a Python file. And if I save this, in this case, I'll save it to my desktop. And now we have a Python file saved, and I can do the same thing. I can say print my name. But it doesn't execute it. So it's just making a file. So if I go here and I say run, it's now going to run that piece of script. It outputs my name. The nice thing about that, though, is now I have a script and I can start writing more information, more code, and then I can save it and I can keep iterating and making it better. You couldn't do that in the Python shell, but you can do that here. One thing about idle, though, it is a bit clunky compared to a Jupyter Notebook. So we're going to quickly do that. Open up a Jupyter Notebook from the command prompt. There's 2 ways to open Jupyter Notebooks. And if you go to page 4 in the instruction, I mentioned one way. And there's pros and cons to doing it this way. But if I start typing in Jupyter, so JU, the first thing in Windows it's going to give you is a Jupyter Notebook, and it's going to say open. It'll take a few seconds. It's going to open a command prompt, and it's going to get the environment in place to actually run the Jupyter Notebook. And if you try this, you'll see the same thing on your end. So it's opened the Jupyter Notebook, but what it's done is the starting location of this Jupyter Notebook is going to be your user directory in Windows. So this is my user directory. I can go to my desktop. I can create a new file if I want to, and we're going to do that right now. So I'm going to say new, and I'm going to open a new Jupyter Notebook. And here it is. So here's my Jupyter Notebook. I'm going to do the same thing I've been doing all along. This time I'm purposefully going to create an error. But one thing you'll notice is that it did open and close string syntax on my string, but I'm going to make it do an error. If I hit run, it tells me there was an error. But now, because it's an interactive notebook, I can go right back up to that cell and fix it. And it automatically, it lets you fix it, it lets you save it, and it gives you immediate results when you run that cell. This is really powerful. There's a lot of features in this and a lot of functions that you can do, a lot of widgets. There's a lot of piece with this interface you can get into, such as, and this is very similar with ArcGIS notebooks, and we'll get into that when we get into the notebooks themselves. But this is how you can do it from outside of ArcGIS Pro. So then the best way to do this, to shut this down properly, is say close and halt. It leaves the page, and then I'm going to say quit, and then it shuts down the server on the back end. But I said there's another way to do this. The other way to do this is from the command prompt. What you can do is you can change your directory, because one thing I mentioned is it's in your user directory is what you saw, but your code may not be there, or what you're trying to work with may not be in your user directory. It might be somewhere else. So what you can do instead is you can, just like you would any command prompt, you can go to the location where you want to open it. And I'm going to do it on the D drive. So if I go to the D drive, and now if I type in Jupyter Notebook, and this is not in the notes, it'll do the exact same thing. It'll open up Jupyter Notebooks, but this time, instead of being in your user directory, it's actually going to be on your D drive. So that's a way to really easily get in and move around your system. Pardon me, I got to move this out of the way. So using the Python command prompt the way I have, you can bring up Python, you can bring up idle, and you can very easily open up Jupyter Notebooks outside of ArcGIS Pro. But now what if you want to do this, the same type of things inside of ArcGIS Pro? So I'm going to close down the command prompt. And now if I go down to my search window and I type in ArcGIS Pro, and for those of you who have not used Pro before and are not familiar, I'm going to give you a quick lay of the land inside of Pro so you know what's going on. And in this case, I'm going to create just a new project instead of using one of my existing ones. So I'm going to go up here and say new project, and I'll let it be called my project. You can make it whatever name you want. And what you're going to see when you open up ArcGIS Pro is you're going to have a table of content, a contents pane on the left. I chose to have it add a map. So here's a map view. And then I have a catalog pane. On top of that, you have a ribbon, and this is a contextual ribbon. What that means is if I had a feature layer, like a vector layer like points, lines, or polygons, if I had a layer like that in here, and we'll do that when we open up a project package in a minute, this ribbon changes to be things you can do with that type of data, and we'll go into that. But we're going to use the ribbon right now to really get in and show you how to open up our different ways of interacting with Python from within ArcGIS Pro. So right here, we are now in, I think it's page 5. And if you were to go up to the Analysis tab or the Insert tab, either one, and you're going to go in and you're going to say New Notebook. What you'll notice here in the catalog pane on the right is there's nothing here. It just says maps, toolboxes, databases, styles, folders, locators. There's nothing that indicates notebooks. If I go up here and I click New Notebook, what's going to happen is in the content in the catalog pane on the right, all of a sudden you see that there is a notebook pane, a notebook, not a pane, but an item folder. If you expand it, you can see your new notebook. And right now it has a generic name. You can always go in here and rename it. It can be anything you want. And here is basically what we were seeing in the Jupyter Notebook. ArcGIS calls them they call them ArcGIS notebooks because there's a slightly different flavor than Jupyter Notebooks, but they're built on the same technology. So once again, if I want to do that basic code I was showing you earlier, once again, if I do a print statement, it auto completes the string. And if I hit run, it's going to do it for me. It'll run it. It'll show me the output. And I can come up here and hit save. And then that test.ipynb or IPython notebook will save that to it. And you can open it up later as part of your project. So it works really well. You have to use the save button up here in the upper left to save the notebook. Just saving the project does not save the notebook. So note that. Also, I mentioned there are some basic functions inside of Jupyter Notebook, and they're across the top here. There's the edit, and there's a bunch of features you can do per cell. You can view, you can toggle line numbers. I mentioned that this is something I do often. And the reason for that is if you have an error, it'll actually tell you that in the code. It's going to be very unhappy with that. It's going to say that there's an issue on line 1. And it gives you the line number where it occurs. You can also do insert, and you can insert new cells, different types of headings. You can run different cells. You can convert the type of cells, and we'll go through this in a little while. Also, you can get to help information. One thing I find very important when using notebooks, and you'll see this as you move through the process and as you do it yourself, there's this little keyboard, open command palette. There's a lot of commands that are exposed via this that you don't always see unless you go to that little icon in the upper right where it says open command palette. So this is how you would open up Jupyter Notebooks inside of ArcGIS Pro. Once you have the folder for notebooks, you can right click and say add notebook, where you can add one existing notebook to your project. You can also create new once that folder exists. But before it exists, you have to insert it either by the Insert tab or the Analysis tab. One thing I noticed is I jumped ahead one step, and you can open a Jupyter notebook, but you can also open a Python window inside of ArcGIS Pro. And this was the old way until relatively recently to work with Python inside of ArcGIS Pro, as well as inside of ArcMap, the previous version of the GIS software from Esri. If I click on open the, if I click on that to open that Python window, you basically end up with the equivalent of the Python shell, but inside of Pro. So if I was to say, once again, print my name, it works the same. When I hit enter, you have the output or the transcript of what you just did. So in this case, print Shane, and it keeps track of what you do. But unlike the Python shell, you can save the results of this and create a Python file out of it. Similar to with idle, you can do that here by right-clicking in the intermediate window. Is it going to work? You right-click on the script and say Save Transcript, and it gives you the option to save it out as a Python file. So if I go up here, go to my folder, here's my test, and I can always overwrite it, but I won't. And now you've saved the output of that Python window to a Python file. But I tend to like Jupyter Notebooks. They're easier to work with, easier to work to navigate and to develop code in. One thing you may wonder though is, and I don't think I go through this in the scripts, in the exercises, you have this Python file that you're generating your script in. The way to export that out to a Python file is you go up to Edit, and I can't see it. One of the options, where did that go? Oh, hold on. Notebook, export, and then export to Python file. And that will also save it out as a Python file that you can use and share with others easily and use as modules if you've done a really elaborate script. And you would also go in and just save it to your current location. And I'm going to call this test 2 or test 3, doesn't matter. And now we've saved it out. Another thing you can do beyond saving the Python script is you can actually export that view out as a HTML file that you can then share with GitHub so people can see the output of your script, or you can just make an HTML page out of it and share it on the web. So there's a lot of power there. So what I really just want to highlight here before we get into the tools more is with this, you have the ability to open up notebooks. You have the ability to work with Python both inside and outside of ArcGIS Pro. So with that in mind, what we're going to work on next, we're going to slowly shift into the first notebook. In that notebook, we're going to go over basics. We're going to go over different types of variables. We're going to go over not only variables, we're going to go over sequences, and we're like range values between 1 and whatever. We're going to go through different ways of doing loops and conditional statements and how to get user input. That's going to be the next thing we work on. But one thing I want to show you before we shift gears and take a break and then come back and do the first notebook is you keep hearing about virtual environments. You keep hearing about different Python environments, and you keep hearing about package management. It's very important in Pro because the first thing they do when you install Pro is they give you a default environment, and they don't let you add or change that environment. So if you want to add third-party packages, you need to go in, clone an environment so that you can go and add more packages to it. One nice thing about that is by cloning the environment, you're not going to corrupt your existing notebook, your existing environment, sorry, not notebook. And if you, in that way, if you do something and you install a wrong package or you upgrade a package and it breaks your environment, you can always go back to your original one. So do this to create a new environment. You're going to go back, go to project. Don't do this now. Go to package manager. Up in the upper right, you can see the active environment. This one is one I created because I use ArcGIS Pro every day. I have a handful of environments that I have that have other packages in it. But to develop this workshop and to make sure everything worked proper for a new environment, such as what some of you might be using, I actually cloned the default environment and gave it a name that you see here with NB as the suffix to really specify that it's the notebook. If I click on the cog, you can see here's the default environment, and I can go in and clone the default or any other environment by just clicking on it, choosing the three buttons, little three dots, and say clone. I'm not going to do this right now, but you'd give it a unique name and hit OK. It's probably going to take 5 to 10 minutes to clone the environment, but then you have a new environment that you can add script, you can add packages to, and it's not going to impact the default environment, and you can then use that inside of ArcGIS Pro. So it's really helpful to have this. Once you have an environment, you can add new packages to it. It's a Conda environment. I don't know, I can't remember what Conda stands for, but it's a package management. It's actually a package repo. They store a bunch of different packages, and they have a system for adding packages to environments, and it's integrated into ArcGIS Pro. So right here, you can see I have 225 installed packages. I can use the package manager inside of ArcGIS Pro to add new packages. So if I click on add packages, you can see there are over almost 9,000 packages that I could add to Pro. So if I wanted to, I could come down here. I'm not going to do it. I could write Aster. I could install Aster, click on it, say install. It's going to go in, it's going to install that package into your environment, and then you'll have that to use inside of your code. There are some instances where the package will not install properly, and there are other methods to install packages. And Esri recommends that first you try to install your packages with the package manager from within ArcGIS Pro. If that does not work, what you can do is you can go back to that Python command prompt, and you'll see it in your notes, in the notes about installing packages. There is, you can use Conda outside of the package manager, and it's written here, but basically it's Conda install, and then whatever the Python package is. And you can do a search online if you know what the Python package is. You can basically type in, for instance, docx, which is a package that allows you to work and create Word documents. You would search for Conda docx, and it would give you the path to use, and you would type that into the command prompt, and it'll install it for you. Sometimes that package is not available in Conda, and then it's available in another system, and it's called pip, and you can actually install via pip, and that's a simple thing as pip install and the name of the package. And if you search for these packages online, it'll often give you an instruction for installing with pip or Conda. And ArcGIS Esri recommends using their manager, then trying Conda, and as a last effort, try pip, and it's in that order. So keep that in mind when you're installing packages and you're trying to use third-party packages in ArcGIS Pro. So that's the basics of what's available from Pro, what's available outside of Pro and inside. So with that, let's take a break. It is now 1:54, so let's take a break until 2 o'clock. Then we're going to come back. We're going to open the project package that I hope you all have downloaded, and we're going to start working through exercise number 1. And we're also going to make sure that the CalAdapt Pi Python toolbox is installed and working properly, and that you can open Jupyter Notebooks, and just to make sure everything's working before we get going. So let's take a 5 to 6 minute break, and we'll meet back here at 2 o'clock. And if you have any questions or comments, please put them in the chat, and then we'll start back up in 6 minutes. So welcome back, everyone. So I just want to quickly do a quick DVHS real quick. I realized I could show you all quickly ArcGIS Online and their notebook implementation. So if you have an ArcGIS Online for organization account through your organization or who you work with, you potentially have access to Jupyter Notebooks or notebooks. As Maggie mentioned, you'll see it in the upper header between scene and groups. You'll see notebooks. If you do not see notebooks up there, what that means is your organization hasn't given you a role that has notebooks as an option, and you would have to ask that. But once you have that role, you can go in and you can create standard you can create different levels of notebooks. One that has GPU support, one that has just an advanced with like workflows for machine learning and more packages installed, or just the standard. And these are available inside of ArcGIS Online, like Maggie had mentioned. The same things we're going to show you inside of ArcGIS Pro in general work here. And like Maggie mentioned, there is a Python API for ArcGIS, and that's really geared towards using ArcGIS notebooks, ArcGIS Online notebooks, as well as notebooks within ArcGIS. But you can see how the same environment is up on ArcGIS Online. And that's all I wanted to say about that. I just wanted to show you that it's available. So now what we're going to do is we're going to get into the nitty-gritty and really the meat of this workshop. And this is going to be working with notebooks inside of ArcGIS Pro. So one of the things that Sean sent out earlier was a link to a project package, and the project package is called Notebook ArcGIS Pro Workshop, and it's got yesterday's date because I made some changes and republished yesterday, and it's a project package. When you click on that file, what it's going to do is it's basically going to uncompress that file into your user directory to the Documents folder, ArcGIS Packages. Inside the Packages folder, you're going to see that notebook ID with a unique ID at the end. And it'll actually open that inside of ArcGIS Pro for you. I'm going to go in because I've already done this, and I've got some number 4, the longest part, the notebook 4 has been complete, just so I can show you it. So, but here it is. Here's the notebook workbook workshop APRX.
At that, could you try again?
Pardon me. I'm having to mute Siri. So here I'm opening up ArcGIS Pro. And this should be exactly what you see in your project package if you open it up. And not if, but when you open it up. In the contents pane on the map that opens, you're going to see academic footprint home locations. This is a data set that IGIS has created in connection with a project within the University of California Agricultural and Natural Resources group that we belong to. And this is where we have academics stationed all around the state doing work for the people of California. And that is what this academic footprint home location data set is. We also have the REX layer is the locations of research extension centers around the state of California. And we have 10 of them listed here in this data set. As an example, here's a polygon layer that represents that research extension center. There's also a select REX. So for the examples we're going to work through in workbook number 3 and workbook number 4, we are going to use the select REX. And then, of course, we have the counties of California. The counties of California and the academic footprint home locations are coming off of ArcGIS Online, and they are available for you to use in this map. If you look on the right-hand side in the catalog pane, and you go to notebooks, you're going to see 4 notebooks that are in there. we are going to open up for this next exercise, Python Basics, notebook number 1. And I want to point out that a new version of ArcGIS Pro was released just yesterday. So we've done some testing, tried to see if there are any glitches. And we have noticed 2 things that are weird between the old versions and the new one. You might find that you can't open Jupyter Notebooks right away. So you may get an error, can't open this notebook. Or under the toolbox, this CalAdapt Python toolbox may have a big exclamation point next to it. And all you need to do to get around that is go up to project if you have an error and just say save project as, and go into the folder and save the project, give it a new name, and then everything will work fine. Why that is, I'm not sure, but that is the workaround. And Robert, Ben, Andy, and Sean know how to get around that. If you have an issue, just put it in the chat window. Okay, so here's the Jupyter Notebook, and what we're going to do, and I tried to highlight learning goals for this notebook. So we're going to show you how to create variables. We're going to show you the built-in types so you know how to work with them. These types include strings, integers, floats, booleans, lists, tuples, and ranges. We're going to show you how to merge different ways, how to merge strings and numbers. And there are many different ways to do that. We're going to show you one. We're going to show you how to do a for loop and a while loop, how to do if, else statements, how to get user input, and how to make your own function. So we're just going to go through this step by step, and this is going to give you the basics of what you're going to need to work within Python. Really straightforward, pretty easy to use. So right here in cell 1, and I should point out that these top cells, they're using Markdown, which is a language that I think was originally developed, and I could be wrong, but it's used often in GitHub. And if you click on it, you can see the syntax. And so in this case, it's a Markdown cell. If you run it, it just doesn't run code. It's just a way to give headings, to give more information and stuff like that. So when you see headings or information blocks, they're using Markdown. We're going to use code in most of these situations. But you can also do headings and raw and notebook convert. I've never used that, don't know what that is, but I have used headings, Markdown, and code. So let's get into basics. So how do you define a string variable? So right here, we are going to show you how to define strings. And also, as you can see, we're also going to do Boolean, integer, and float. So right here, I'm defining a variable called name, and I'm giving it my name. It defines it to name just by doing that. And then I'm going to say print it. So I'm going to say print in parentheses name. The parentheses are very important. In Python 2, if any of you know the older version of Python, you didn't need the parentheses. But in version 3, you do need the parentheses for it to work properly. And if I hit print on that, it'll print out my name. But one of the interesting things about notebooks is you don't have to put the print statement. I can just put the variable and say run the cell. So in this example, it's going to create the variable, it's going to print it, but it's actually going to print it twice because of this last piece. So if I run that, you can see it printed it first, so Shane Fire. And then this last piece where I just said Shane, it puts it as the output. I just put name, sorry, not Shane. And it outputs it as a string, and it shows you it's a string, Shane T Fire. So feel free to quickly try and modify that and see how that piece works. And it's important to note that when you're doing strings, you can have single quotes or double quotes. So if I was to do the same thing with double quotes, in Python, it's still a string. It knows how to handle that. You just can't use one of each. It will not, you get an error if you do that. So that's how you create a basic string. So now if you want to do an integer value, if you want to define an integer, so what you can do here is we're just going to say define a variable num. We're going to give it a number. So in this case, 20. We're once again going to say print it. So you're going to get 20 out as you'd expect. And then we're going to do some mathematics with that numeric value of the integer of 20, and we're going to multiply it and print the results. So what you see is 20, and then the number times 2. So it's kind of what you'd expect, you know, and because we put in a integer value of 20 with no decimal place, it's going to assume it's an integer coming out, and it's going to be 20 with no decimals. Second. Okay. Now Boolean. So Boolean is it's basically 1 or 0 or true or false. So in Python, it's not 1 or 0, it is true or false. It's capital T, capital F for false. So if I was to go in here and say the choice is true, so TRUE, I'm then going to print that so you can see it. And then I'm going to do really quickly an if-else statement. So if choice equals true, print out choice is true, else print out choice is false. So if I run that, you're going to see true, and then the choice is true. And that's a really, really basic if statement. One common mistake I'll point out, and I guarantee anyone who's a programmer on this call has probably done this. If you say if choice equals true, equals true, it's not the same as equals. And if I run that, I'm going to get an error because it's not actually testing whether choice equals true. It's trying to set choice equal to true. So if you're dealing with loops and logical statements, make sure that if you're doing an equals test, that it's equal. Otherwise, you will get an error. And all of us have run into that problem. So pay very close attention to that. And as this pro tip says, it needs to be capitalized. You can't put lowercase t and lowercase f. So integer values. So let's have a look at integer values. So here, if like I mentioned, integers up above a number. So integer is equal to anything without a decimal place, a whole number. So in this case, 10. If we go and we run this cell, what we're going to see is we're going to see the number 10. And then here, by specifying this function type, it's going to go in and it's going to figure out what type num is. And if we run that, it's going to say integer, int. If we, in fact, I can show you that. If I come here, I'm going to do a block comment out by just doing 3. So here, number equals 10, and it's going to tell you it's an integer, int. But what if you want to have it be a numeric float, or a float value with decimal places? If you just define it with like a decimal place, it will know that it is. It'll know that it is a float value, a float type, and I can show you that by commenting out the next line. So here you have 10 equals integer, 5.1 equals float. So it can figure out or discern what it is by how the variable is defined. Now in this one, the last thing, we're going to try to convert the num1 5.1 to an integer value. So let's see what's going to happen when we run that. So when you run and you convert it to an integer, as you'd expect, it's just going to truncate the variable. So from 5.1, it becomes 5. So by saying, by setting it to int, converting it to int, it'll just truncate the data. And I'm going to test something. So if I was to go to 5.6 instead of 5.1, is it going to truncate it at 5, or is it going to round up to 6? Let's see what happens. So in that case, it rounds, it doesn't round, it just truncates at 5.6 to 5. There are ways around that. And now that I brought this up, I should probably mention it. So if I was to go here and type in round, you can get it to round up and produce an integer value. So now we've looked at strings, we've looked at integers. So now let's look a little more at floats and how to convert back and forth. So here we define a number variable again is 10.0, which should mean it's a float. And once again, I'm going to block out a section of code by doing 3 single quotes. And in Jupyter Notebook, that automatically, if you've got it selected, will basically comment out a block of code. Now, if I run this, we're going to see 10.0 is a float. But now let's see what we can do with that. So once again, we're going to define a variable of num1. It's going to set it equal to 5. And if we, and it's an integer, if we go in and we run that, so now we're going to, oh, syntax error. Oh, pardon me. So here you can see, once again, you have a float variable and an integer variable of 5. So you got 10 and 5. But now how do we convert that 5 to be a float? This next piece is just going to convert 5 to be a float. And if it works properly, it should be 5.0. And it is. So what we see is up above, we can convert to integers by typing int. And if you want to convert a float to integer, you would say int. And if you want to convert an integer to a float, you convert it by saying to float. Really straightforward, really easy. One thing I should also point out is if you want to convert that to a string, it would just be str for string. And then you have a string value. So that's working with strings, floats, and integers. Now, one thing we should point out is strings, and this is going to sound weird, but strings are immutable, so you can't change it. So when you define a variable of string, you define string, like in this case, you define a string, in this case, like string 1. This is a string in Python. You can't go in and easily change that unless you recreate string 1. You can't drop a character. You can't do anything like that. You have to actually go in and create the variable again. It has to be instantiated. If you don't, it's just not going to do it. You can't sort the characters. You can't do anything like that with it. It's not changeable. So keep that in mind. And once again, here we're pointing out that it's single quotes versus double quotes, and they are the same thing. So now one thing you may need to do in your programming and what you're trying in your programming projects, and as you're getting through things, you may need to concatenate variables together, whether it be for names of things, whether it be to create variables, whatever it is. To do that, you're going to have to concatenate data. The most basic way of combining 2 strings together or 2 pieces of data together is just by a plus symbol, like you can see here. In this case, howdy partner. If we do this, it's going to create howdy partner. But what you're going to notice is the first howdy is there, and we had to put an extra space in that second string so that you get spaces between the 2 words. But the plus symbol will concatenate. It's not the best way to do it, though, and you'll see that in the next example. So we're going to try to concatenate or combine a string and a number variable. And what we're going to see is it's going to give you an error. And the reason it's erroring is you're trying to add together a string, an integer value, and a string. You can't do that in Python. But what you can do is you can convert, as we saw above, that integer value into a string and then you can combine it. So in the next example, we're going to take that value of 4, we're going to convert it to a string, and when we run that, it'll actually combine it together and not give you an error. But there is even a better way to do this. And like I said, there are many ways to do some of these things. In this case, we're going to use string substitution. So if I hit run, I'm going to go in here now, and I've written out my string. So in this case, I'm going to say, I want to get out of it, I'm feeling really outstanding today, because I am. But I may want to change this variable. I may want to add something else. But first, we're just going to do this basic thing. So I'm feeling really something today. Here's the variable I'm going to substitute in. It's %s. So whatever I put after this, the following %, is going to be inserted into this text string. So in this case, what I'm going to see when I run this is it's going to say, I'm feeling really outstanding today. And, it seems similar to what we did above, but now because I'm telling it to insert it into the existing string, I can put an integer value in here, and it's going to automatically convert it to a string and insert it into the statement. I can do the same with a floating value. It'll insert it into the statement. So that's a really nice way to actually work with strings and concatenate and create knowing variable names, knowing strings, whatever you may need. Also, another nice strong thing about using that method is you can do more than one variable into that variable substitution. So here we're saying, here's the first piece that I want to substitute, in this case 1, and is smaller than the second piece, 2. This is not a numeric test. This is just constructing a string. But if I run this, 1 is smaller than 2. It inserts those 2 values into the placeholders that I put in place. And I use this all the time. There are multiple ways of doing this. Once again, this is one of them. So now you might be thinking, okay, so this is how you work with how you create a variable. But now let's say you want to really do something different. Let's say you want to create a list of things. And the reason you may want to create a list of things is to go through and let's do a for loop. So you're going to do something to each one of those items. In ArcGIS, there's actually a way you can tell the program to give me a list of all the layers in the table of contents. And it'll return an object similar to this. It'll be a list that contains an item or an object. So in this case, we're creating a list of objects, and these are just strings. So we're going to go through, and if I was to run this, you can see it's a list. And how do we know it's a list? Is because in Python, if you see anything with surrounded by square brackets, that means it's a list. You can have lists of lists. So I could have another list inside of here. It's going to get a little bit complicated, but not too bad. And this is totally valid. So now you have a list inside of a list. Lists are nice because they're mutable. You can change them. What I mean by that is I could go into this example right now. Hopefully I get my syntax right. I can go in and let's see if I get this right. So I appended Shane to it, so I was able to add to the list. In a type I'm going to talk about in a second called a tuple, you cannot do that. So now we have a list with 5 items, and because it can be modified, it can be changed, it's mutable, I can sort it. So I just call sort, and now we have an alphabetically sorted list. And you will have to do stuff like this in Python quite a bit. Here's an example of a for loop that's going to use that list. So I'm going to say for each item in the list of A, do this thing. So for I in A, so it's going to be these 5 items, I want it to print out I. So then when I do this, it's going to go into the first one. It's going to say, it's going to go bar. Then the next one, next line, it's going to say Baz. Then it's going to say foo. Then it's going to say cucks. Then it's going to say Shane. So if I run this, it's a basic for loop. And something that's really important in Python, so you have this list. There are instances where you're going to want to pull out very, very distinct items from that list. So here are different ways to do that. So the first example, I'm going to go to that list and I'm going to say, give me the first item. And what you're going to see here is I'm saying, give me 0. In Python, everything is, it's a 0 index system. So 0 is the equivalent of give me the first. So if I say 0, it's the first. So if I say give me 0, that's going to give me, because I sorted it, it's going to give me bar. This next line is going to give me the last value. So it's saying go to the end and work 1 back. So in that case, it's going to give me Shane. The next one's a little more complicated. Now, this is going to give me a chunk of data, not just one variable. This is going to say, give me the first value up to, but not including, the third value. So this is going to give me the first and second values. Sounds weird because it's saying 0 and 2, but it's going to give me bar and Baz. And that's what it does. Then the last example, make sure I'm doing this right, thinking this through. First and third and fourth. I'm confused as to why it's giving us that. Okay. This is going to give us, I believe, every other, if I remember right. So it's going to give us the first, and it's going to do it every other. So it's going to do it every 2. So it's going to be the first value, the third value, and the 5th value. If I was to change this to 3, it should only give us 2 values. And that's going to give us the first and the third and the 4th. So it's going to skip 3 or skip 2, go to the 4th. So this is the equivalent of the first, the last. In this case, we're not specifying last, by a step of 3. Or previously a step of 2. Does that make sense? Give me a thumbs up if it does make sense, because you will use this quite a bit. So here's something just for you to try. In the code block below, try to create a list containing the top 3 favorite flavors of ice cream. And I will do that with you. And if I run that, you will see that I do have a list. There's my list. And if I want to sort it, this is the nice thing about Jupyter Notebooks. You can go back to the cell and redo it, and this time sort the values. And then if I run that, you can see the values are now sorted alphabetically. Hopefully you were able to do that. So that's the basic of lists. And like I said, you use lists a lot, and there are specific ArcPy functions that are written to work within ArcGIS Pro, to work with layers, to work with maps, to work with layouts. that provide lists that you can then work through. The next data type or data structure that we should know about is tuples. Tuples are very similar to lists. However, they are not mutable. You cannot change them. You can't sort them. You can't append to them. Once you make them, that is what you get. And how you know you're dealing with a tuple is because they are surrounded by parentheses instead of square brackets. So if I run this, it's going to create a tuple with these 6 items in it, as you can see right here. And once again, there's like in everything in Python, it's 0 index. So here I'm saying, give me the first item, and it gave me foo. I said, give me the last item. It gives me Corg. And then I'm saying, starting at 0, starting at the first item, give me every other item. Oh, I take that back. Take that back. This one says, starting at the first item, give me everything up to but not including the third item. So it's going to be foo and bar. If I wanted to say, give me every other, once again, I'd add another semicolon. And I would say, starting at 0, going all the way to the end, give me every other, every second. And it does exactly that. Once again, I can use them in a for loop, just like we did a list. I can run it. But one thing you're going to find if you try this last statement, the next statement, and I run this, I'm going to get an error. And the reason, once again, I get an error is because it's not mutable. You cannot change a tuple. Now I want to try something. I haven't tried this before. Let's see what happens. Nope, that's not it. There's a method you can use, and I don't know what it is offhand. I took a guess, but there is a way to convert tuples to lists, and then you could sort it. There's often workarounds for issues. You just have to search, and you can find them and figure it out. So now we've shown strings, integers, Boolean, true values, floats. We've shown you the basics of lists as well as tuples. But now we're getting down to something that's slightly different. Let's say we want to look at a range of values. So you know that you may want to handle, like, do something 20 times. Or you may want to work with a range of dates, something like that. So in this case, we're going to look at trying to do something in a certain number of times. So what we're going to do here is we're going to do a for loop based on a range. Up above, we did it based on a tuple, or we did it based on a list. Here we're going to say, give me a range up to 10. And we're going to say for each item, we're going to print the item. If I run this, because it's zero-based indexing, what you're going to see, it's going to be 0 through 9. So the range is basically 0 up to, but not including 10. 0 through 9. Also in the range, you can say, don't start at 0. You can say start at you can start at a specific value. So in this case, I'm going to say start at 1 up to, but not including 11. And I think this will give more what you'd expect for 10 values. So instead of being 0 to 9, now it's 1 through 10. And then also, like with tuples above and lists above, you can also tell it to start on a certain variable, like we did above from 0, go to, but not including, in this case, 11, or 2 to 11, but now we're going to skip every other number. So if I print this, it should give me 2, 4, 6, 8, 10. And indeed, that's what it does. And I could do this if I really wanted to be crazy. I could go all the way to 101, and it'll give me 100 values, skipped every one. And that's a really easy way to create an iterator, I can never say it, of a series of values, of numeric values. And this will often be used in scripting and in for loops, and potentially, you wouldn't use that in a while loop. So now you have a range of value or sequences. So then how could you use those? So we're going to use those in loops and iterations and loops. So a loop, there's basically a set of instructions that you tell it to do. So you're going to say, do it a certain number of times. So if we use the list or range, you would, like we did earlier with that print statement, you're going to say, go in, do that. In this case, it's going to be 0 through 9. And you could put in other code here, and you could have it do very specific things other than print, and it's going to do it 10 times. And in that case, you have it's a definite number of times. You specify it, it does it. And that's a for loop. Really easy to do. Here it is. We've done it above. You've seen it. But there's another type of loop, and this is an indefinite loop. And what this means is you're going to do something until a certain condition is met. So it's almost like a if statement, but this is a while. And what this means is do something as long as or until you meet a certain value. So in this example here, what we're going to do is we're setting a variable equal to x, and right now it's 0. And I'm going to tell it to loop through and print the value of x as long as x is less than 10. And you notice here it goes into the loop while x is less than 10. It gets in there because the first time it's 0. It's going to print it. It's going to say 0. And now after that print statement, I'm going to go in and I'm going to increment x by 1. That's what this piece here means. Add 1 basically to that variable. So increment x by 1. So this is going to run 10 times, just like the for loop, but the difference now is it's based on a value that I'm changing inside the loop itself. I could make this 100. I could make it anything. I can make it part of a calculation. You got to be careful with while loops. The reason I say that is if you don't have your logic right, you could create a situation where you never meet the variable to stop it. And it becomes an indefinite loop. So you got to be careful of that. I'm sorry, an infinite loop, not indefinite loop. So, and I'm not going to do it because it'll have to stop the kernel. But if I was to go in here and say x is, go until x is less than 0, and if I set x equal to 0 and I'm incrementing it by 1, it'll never finish that loop. It'll just keep going. So keep in mind there's for loops and there's while loops. Now we're getting down to one of the meats, or one of the things that I use often, is conditional statements. So there's a conditional statement. There's a basic one would just be an if statement. So if this, then you do that. You do this piece of code. So in the example below, I'm going to go through a range of 10 values. I'm going to test it, and if it equals 5, print you reach the number 5. Otherwise, just print I. So the if statement is just saying that the test I'm doing is what is the value of I. And if I run that, what you're going to see is it's looping through 0 through 9. When it gets to the fifth item, that's number 5, not the fifth item, it's actually the 6th. When it gets to number 5, it's just going to say, oh, you've reached that number. Basic if statement. But what if you also wanted to say something more like, if I equals 5, else do this. So you want to do something when it's not equal to 5. Because right here, you only do something when it equals 5. So this is an if-else statement. So the same thing, you reach 5, but then you're going to say else. So you're not on 5. What do you want us to do with it? We want you to print you reach the number. Very similar to the one above, but you're using additional logic inside that block. Now there's even a more complicated case. You've heard of if statements. Now you've heard of if else statements. There's a third. There's an if, an elif, and an else. Elif is the equivalent of, okay, so we have an if, and then you say, okay, if it doesn't equal to 5 in this example, well, does it equal to something else? So does it equal 6? So does it equal 5? If so, do this. Ooh, but does it equal 6? If it equals 6, do this. Otherwise, do the generic. So in this case, we're going to test if it's 5, say it's 5. We're going to test if it's 6, and then print the second best number. And I'm not at all biased towards 5, so don't hold that against me. But then if it's not 5 or 6, just print the number itself. And if I run that, you're going to see exactly what we just described. So by doing an if, an else if, or an elif and an else, you can have more fine control of what's going to happen. And you can have as many of these statements inside here as you need to define the different cases of if something happens. So those are the basic conditional blocks you're going to use for creating your conditional statements. They're if, elif, and else. The most basic, you don't need the elif or the else part of it. You just need the if statement itself. And keep in mind, once again, equals equals is not the same as just equal. And then anything else when it comes to conditional statements, greater than, equal to, less than or equal to, not equal to in Python, not equal to. So you can see that there's different ways to do this, and there are different tests you can run. So one thing we saw earlier that there are like almost 8,000 packages on Conda. I don't know how many more that are available via pip, but there are going to be certain situations and things that you're going to want to do that no one else has had to do before. So within Python, you have the ability to make custom functions or user-defined functions. The most important piece of this for defining one is this statement right here, def. So I'm defining a function. In this case, I'm going to basically take a list and I'm going to multiply all the values of that list together and output the amount. So I'm saying that the name of the function that I'm defining is going to be called list product. The inputs are going to be a list. There's an optional value, an optional parameter that you can have, in this case, a multiplier. And by default, if they don't put a multiplier or a second value into this function when they run it, it's going to assume 1. That's going to be the optional value. And then inside this function, I'm defining a variable, and it's going to be called product, and it has 0. And now I just loop over the items in the list. And what I do is I take product and I increment it by I times the multiplier. And then when it's all done, I'm just going to return back to the thing that called the function the value of product. Pretty straightforward. If I run this, now if I was to insert a cell above, what I'm going to see is I should have a function sitting here. What is that now? Okay. Jupyter Notebooks usually have a type ahead function that you can hit tab and it'll show you things that are named that. But sometimes it works and sometimes it doesn't inside of an ArcGIS notebook. Let me try something. So if I say list product help, what it's going to do is if I say help and then type the name of the function into it, in this case, list product, it'll tell you what the inputs of it are. So even if this was way up in your code or someone gave you a module that had a bunch of functions in it, you can figure out what it's going to take. So in this case, a list. And because I see this has got another parameter, but it's equal to something, means it's optional. So here I'm going to go in and I'm going to multiply 1 times 2 times 3 times 4, which is going to be list 1. And if I run that, you can see, I'm sorry, I'm not going to multiply, I'm going to add it together, but with a multiplier. So what's 1 plus 2 plus 3 plus 4 equals 10. The second example, I go in and I say, okay, you're going to do the same numbers, but I'm going to multiply each one of those items by 10. So now it's going to be 10 plus 20 plus 30 plus 40 equals 100. Makes sense. One thing I want to point out, though, is you see how I've called it list one, and it matches what's in the function list one. It does not have to. If I call this list temp and I use that inside that custom function, it'll work exactly the same. So all it's checking for is that it's a list. As long as it's a list, it's going to work. So that's how you create a custom function. That's how you see what the parameters of a custom function are. And then this right here is how you use the custom function. The last piece in the Python basics, I don't use this very much because I'm often coding for myself and for my projects, but you may have an instance where you're going to share this with somebody else, or you're going to have a Python standalone code and you want to get information from somebody. So in this case, here are some command prompts that you can ask the user for information. So here I'm saying input. I want input from the user. This is the question I'm going to ask, and I want the answer to be saved as text. And then here I'm going to print out what they say. Same thing here. How old are you? You put it in there. It's going to report how old you are. And you can also test to see by using the type function, what type of value is it that you're getting back from those functions, from those calls, inputs. So here, for instance, where do you live? I'm just going to type in Hopland. And just note, these data are going nowhere. They only reside on your computer. So put in whatever you want. So here, I said I live in Hopland. It says, how old are you? I type in a value. Hey, you are this old. And when it looked at the variable age that you just defined, it's a string value. There might be instances where you don't want it to be a string. You want it to be like an integer. So here I'm using that command you saw above for converting strings to integers, int. So I'm just going to ask, how old are you? Again. And now it says, hey, you're 50 years old, and it's an integer value. So you can use that in mathematical functions because it's an integer, or conversely, you can convert it to a float, and you could use it there as well. So then what you're going to see here now is you can go in and you can try to write a prompt for your own information, to gather your own information. But what we've shown up above is we've shown you the basic data types you're going to use in Python. We've shown you conditional loops, where we've shown you loops, whether they be while or for loops. We've shown you how to generate ranges of values. We've shown you how to create custom functions and how to get input from users. Except for the last of input to users, I use in my programming almost every day in Python. So with that, this is the basics of Python. Do you have any questions you want to ask before we shift gears here and do exercise number 2?
You want to take a couple-minute break, Shane, or?
Sure, we can take a 5-minute break. So be back at, be back at 2:55. Welcome back, everyone. We're going to get going again. So the next step of this is we're really going to start showing how to use GIS functions and geospatial tools inside of Jupyter Notebooks or ArcGIS notebooks. So we're going to open up number 2, first notebook. And what this really is the first notebook using ArcGIS. So we're going to open this up. And this notebook is going to use the data that is in the contents pane. So if I was to come down here, and the first thing I'm going to show you how to do is use the tools themselves. And I'm going to walk you through using the tools, using the geoprocessing tools, and also, as Maggie and I mentioned, the history function. and what you can use with the history window. So the first thing we're going to do is we're going to go in and we're going to do an intersect. So if you go up here, if you don't see the geoprocessing tab, what you're going to do is, oh my goodness, my Zoom controls are in the way. I'm going to go up here to the ribbon. I'm going to go to analysis. And in analysis, I'm going to say tools, and it'll open up the geoprocessing tools. And I can search for, in this case, the intersect tool. So I'm going to go to intersect analysis. I open the tool. And now I'm just going to populate it the way you see here on the screen. It's going to be academic home footprint locations, home locations. And it's going to be California counties. And it's going to tell you that there's a selection of records. That's fine. So California counties, we're going to call it, just to be consistent, we're going to call it ANR. So for agricultural natural resource footprint and intersect. Just so it matches the instructions, and then keep the defaults. If I run this, what's going to happen is it's going to run it. It's going to add a new layer to the table of contents on the left called ANR footprint intersect. So it didn't intersect with the county layer, and now each one of the items that are, each one of those points now have the attribute for the county. So you can see the county name, and what it gives you, basically the county name and where it is. So then we're going to go in and we're going to calculate statistics on that intersected data set. So once again, if I hit the back arrow, this is all using the standard geoprocessing tools provided by Esri and ArcGIS Pro. So I'm going to do a search for summary, and we're going to want summary statistics. So right here, analysis, summary statistics. I'm going to choose the ANR footprint intersect. And it's going to be ANR footprint intersect. And of course, it's not going to use the names we expect, because that would make too much sense. So ANR footprint intersect. And I'm going to say stat, just to be consistent. And I'm going to make it use sim title. And I want a count of how many. And this is basically the academic titles. And then I'm going to say the case is going to be name, which is the county. And I want to do academic titles. So it's going to give me the total count of each one of those academic titles in the county. If I run this, now I have a table that's going to show exactly that. The county, there's a cooperative extension advisor, there's 2. In Alameda, there's 2, there's 17 specialists, there's 8 community educators, and then there's 20 other academics. And then there's 8 people who are 8 positions that are under recruitment for Alameda County. So you have all this information that you got just by doing an intersect. What I'm going to do now, though, I'm going to quickly create a chart of that same information. So if I right click on my data set up above, my intersect data set, I'm going to say chart, give me a bar chart. And it's going to open up the window for bar chart. And what I'm going to set is the name is the category. I'm going to aggregation is going to be count. The type, I'm going to split it based on the type, the type of position, and I want it to be ascending. So if I do that, category is once again name. I want to count, and I want it split by symbol title, and that's what you get. So it's going to give you per county, number of advisors, number of specialists, so forth. And if you hover, you see the values. But you know, you may want to have it look a little different. You may want to do a stack chart. So I'm going to show you how to do that real quick in the chart. So we were on the data tab a second ago of the chart. We're going to go to the series, and we're going to change the type to be stacked. It's really straightforward. So if I go here, once again, the series, and instead of side by side, I'm going to change it to stack. And now you have a stack chart within ArcGIS Pro, and it's going to be saved in the project itself. And here you can see that there's a total of, you know, roughly 55 positions for Alameda County, Yolo County, which is here. We have over 120 positions, and that's because that's where the main headquarters for the University of California Ag and Natural Resources Division. So that's how you would do it if you're using the tools that are part of ArcGIS. But now I want to show you the history panel. So if I go back to the history, the main things we did there, we did an intersect and we did a summary statistic. Now, if I want to do the same steps in ArcGIS Pro in a Jupyter Notebook or ArcGIS Notebook, so we're going to go in, and first thing I'm going to do is I'm going to load the packages I'm going to need. So I'm going to need Pandas, NumPy, Matplotlib, ArcPy, which is actually the interface between ArcGIS and ArcGIS Pro and Python. This right here is going to allow us to create a spatial data frame that we're going to use in Pandas. And then I'm saying ignore warnings. Don't show me the warnings. It's fine. So I run this. It's going to import all those tools, all those modules. And now what I'm going to do is I'm going to just basically tell it what to do. So I'm going to say, get the license from ArcGIS Pro, use the current project, overwrite anything that already exists in the database, and there's nothing in the database to worry about. And then I'm just going to set the basic, I'm going to set the default workspace, which is derived from that. And then when I run this, it's going to set the basic variables, and it just takes seconds. And it outputs and tells me this is where the data is saved, and that's the workspace. But now comes the meat. Let's go in and let's generate the intersect. So if I go down here, I'm going to say, save the intersect. It's going to be called ANR footprint intersect. And I want it to be in the workspace, which is WS. So it's going to be in this notebook. And here's the tool I'm going to run. And I've got it pre-populated with all the information that I know I need to use, including, let me see here, I'm hard coding in the academic footprint layer, which is already in the table of contents. Undo. And I'm telling it to create this feature, this feature set, this feature class on that path. So I insert the path variable. But you might be wondering, where did I get this whole thing from? If I was to right click on intersect, I can come down here and say copy Python command. And I'm just going to quickly show you, if I go in here and paste it, there's the whole Python command that you successfully just ran using the Python geoprocessing tasks. In the new version of ArcGIS Pro, which just released, it stacks all the input variables, so it's easier to read than stringing them all together. But here you can see there's the footprint layer, there's the county layer, here's where we want it saved, and do we want to join the attributes and all that type of thing. So you can get that directly from the history. Once again, so if I run this, let me just run it. It's going to successfully run. It's going to add that layer. It's going to be exactly like what we saw with the geoprocessing task that we ran a second ago. In a similar way, we can do the same thing to get the statistics. So here's the path again, where I want it saved. Here's what I want it to be called. And here's the function I'm going to run. Once again, if you want to know what that is, the proper function, you right click on what you just ran, say copy Python command, come down here and you paste it in, and it tells you exactly what you need. And then what you do then is you just substitute your variables in instead of having the hard-coded values. And I clicked and it moved me off. So here I know that the in table I already know, but what's the output? So the output's going to be path. So I would just substitute this long string becomes path. And then everything else stays the same, hit run. It's a really, like Maggie and I said, the history is a really powerful feature of ArcGIS Pro. It is the recipe. It's what you just ran. So if I run this, it's going to do the same thing. It's going to go through, it's going to create that table for me, and it's all done. One thing I want to point out here is you can go in and you can select and you can say save as a Python script, and it'll save it out as a Python script as well. So there's a lot of options here that you can do with the history panel. And also you can schedule it to run if it's something that you want to do on a repeated basis. You can do that as well. We won't get into that today though. But the history panel is very, very powerful. So now we've redone exactly what we did before with the geoprocessing tools. Now we've done it via Python. So we now once again have the statistics, the stats per county, as well as the footprint, the intersect that we did. But now let's say we want to go a little bit deeper and do the analysis, work on doing that counting piece that we did in the chart. And let's say we want to create the chart, but not using ArcGIS. So here we're going to use Pandas. And Pandas is a third-party tool that's already included in ArcGIS Pro by default in its default environment. And I'm going to go in and I'm going to basically make sure it works. Go to where I have to do it. So Pandas. I'm going to define the input feature class, which we already did up above. That was the feature class layer, which is the intersect layer. I'm going to go in and I'm going to create a spatial data frame out of it, which is going to be used in Pandas. I'm going to create a new variable called from the sim title called academic title. It's a little more meaningful than sim title. I'm going to rename sim title to be position type. And then I'm going to show the first 5 records, or actually the last 5 records from the Pandas data frame. So if I run that, what you're going to see is basically what you would see in this in the table of the data from the chart from ArcGIS Pro. So you now have all the information here. The data is in a spatial database frame, a spatial data frame, and you have academic title appended to the end, and now it's ready to be summarized and then used in a chart. So if I go in here and the spatial data frame is called SDF, that's just the name of it. So I'm going to say SDF. Now I'm going to group all the data by the county name and the position type. And I want to get a count by academic title, using academic title. And if I run this, it's going to give me the data I'm going to use in the chart. So now you see the same information you saw earlier. So here's Alameda. Here's the number of advisors. There's 2. Here's Alameda, number of specialists, and so forth. It gives you all that information. But unlike the previous example where I said, give me the last 5 rows or the tail, here I'm saying, give me the first, and in this case, 10. So give me the first 10 rows. And I can see there's 150 rows in the data set, and there's 3 columns. So that's the shape right here. So now I have the data all summarized. Now let's see if we can get some more information out of it. So I've got the data in here. Now I want to say, what counties have the most positions? What counties have the least positions? So here I'm going to say, let me see, did I call it test up here? Yes, test is what it's called. So the new data frame called test. So now I'm just going to say, using test, give me the record with the maximum value. Give me the record with the smallest value, the records. So if I run this, what you're going to see is YOLO, which is where I said the home office of the UC Ag and Natural Resources Division is located, is the county with the most CE advisors, and that's 13. It has the most CE specialists at 58, has the most community education specialists at 24. However, Alameda County has the most other academics, and those could be various different types of academics, but they have 20. And then the next one is YOLO. There are 12 positions under recruitment. And that's the counties with the most. And if I want to look at the counties with the least, and these are going to be the 5 with the least. Here you're going to the 5 least. It's going to be Del Norte, Imperial, Glen, Butte, and Colusa, and they each have 1 of those positions. 1 C advisor is Del Norte, 1 is Imperial, 1 is Glen. So you can get more information from the data just by running some really basic, straightforward code. These code snippets that I'm using here, if you don't know what to write, you can very easily search online. You can use Stack Overflow. You can go and just ask Google, and you can find out pretty easily using, just type in pandas, do a group by, get the the minimum values, and you'll find this type of information, and you can find it pretty easily and figure it out. So now we have that, we can see more information about it. But now what if I want to get really specific and I want to say, okay, I want to know of all that data, which positions are under recruitment and where. So here I'm going to take that data set that I created, that data frame, and I'm going to say where I want a new data frame called under recruitment. This data frame, or this data set I want to create and hold in memory, is going to be from the test data where position type equals under recruitment. So when I run that, what it's going to do is it's going to give me exactly that. It's going to be a data set that shows all the under recruitment positions from our data set and from California. So, and it's going to be by county. This next line takes that data set and sorts it by academic title. And then it's going to give me an output that how many positions are under recruitment in counties. And it's going to give us the count. And then it's going to give us the first 10 rows. So if I run that, what we're going to see is sorted. YOLO, once again, has 12 positions under recruitment. And here are the next 10. So it's Fresno, Alameda, El Dorado, Tulare. And you can see how many positions are going to be that are under recruitment right now for filling in this next fiscal year. So that's good, but maybe you want to graph it similar to what we did in ArcGIS Pro. So what we're going to do is we're going to use a graphing library called matplotlib, and we are going to graph it. But what we want to do though first is we're going to transform the data from its current format, which is a flat file of name, position type, and academic title. And we are, but it's actually all types, not just under recruitment. And we're going to basically create a pivot table that's going to show by county. And then across the top, it's going to show under recruitment, CE specialists, CE advisors, other academics, community education specialists will be the fields or the column names. And then the numbers will be underneath it per county. And we're going to make a pivot table. So we're going to use a function that is part of Pandas called pivot table. We're going to use the initial data set of SDF, which has all the raw data. We are going to use academic name. The index is going to be name, which is going to be county. And we're going to use the position type. And we're going to aggregate it together and to come up with those values. So if I run this, what we're going to see is a pivot table. So by county, these are the first 5 rows, a pivot table with each one of the types and the counts for each one, which is a good step on doing our table. Now we're going to go in, we're going to use Pandas and the plot function, and we are going to plot that data similar to what we did in ArcGIS Pro. Here, we're going to go in, we're going to create a horizontal bar chart. We're going to have the data be stacked, just like we did in the ArcGIS Pro example. We're giving it the dimensions of the figure, and we're defining the colors we want to use. And these are the same colors, I believe, that we used in the original chart, but they're defined by hex values. So the first value is going to have this value, the first row is going to have, or field is going to have this color, and all the way down the list. And we want the edges of the bars to be white. The title, we're defining that. We're defining the number of positions, the X label, and we're defining the Y label, and then we're just telling it to show. If I run this, we get a chart that shows CE advisors, CE specialists, community educators. It's sorted from least to highest. And you can see all 58 counties in California. And you could export this out and use it in a publication. You can modify it however you need. I know that was a little fast. Any questions on what I just showed you? So that is how to basically take a geoprocessing task, run through the process once, figure out the recipe with the history, and then how to bring it over and convert it into an ArcGIS notebook, and rewire those functions to use your information from your own variables, your own path variables, and make those tools work. And then once you have the data in Python, how to use it in a third-party package of pandas, and then using matplotlib as well as pandas plot, you are then able to further massage the data and produce a nice plot that you have a lot of control over just by you inside of an ArcGIS notebook. Okay, so now with that in place, if there's no more questions, we're going to shift to the third notebook. The third notebook is going to be very similar, but now we're going to tap into an external API to pull data in from a web resource, and we are going to store those data inside of an ArcGIS file geodatabase and further work with the data. To do that, we're going to close this down, and you can see, I should have pointed this out, every time you finished a cell or a geoprocessing task inside of ArcGIS Notebook, it got added to the table of contents. So here's the intersect that we did, and here is the standalone table of the statistics that we generated using the summary statistics geoprocessing task. Okay, so now we are going to shift gears, and we're going to go into the CalAdapt lib intro. The intent of this, like I said, is to really show you how to work with a third-party API, and then also to highlight how to work with that inside of ArcGIS Pro. So once again, I'm going to show you how to use these tools within Pro first, and then I'll show you how to incorporate it into the cells of the Jupyter, I keep wanting to say Jupyter Notebook, but inside the ArcGIS Notebook. So the first process we're going to do is we're going to go in, and we are going to use this Python toolbox, the CalAdapt Python toolbox. We're going to go to CalAdapt API, and we're going to say get data from API. I run that tool or open that tool, and it comes up with this window right here. I'm going to choose the select recs as what I'm going to use as my input feature set. You could also draw and create your own if you wanted to. We're going to use select recs. I'm going to tell it to process all the features individually, because if you don't do that and you just push over a spatial data set to the API, it's just going to merge them and treat them as one feature, and it'll be a different result than having it split out by the individual research extension centers. So I'm going to say process individually. And what do I want to use to be the name of that, of how I want to process? It's going to be name, and this is the name of the rec, so it's going to be the category. And the recs that are in here, the research extension centers, one of them is at the extreme southern end of the state called the Desert Research Extension Center. The other rec that's in here is at the extreme northern part of California, and it's called the Intermountain Research Extension Center. So there'll be a drastic difference in the variables and the data that we pull out of the CalAdapt Climate API, and we should be able to see the results and how they differ pretty markedly. So we chose the name of that select recs. The variable that we're going to look at right now is going to be air temperature. The GCM we're going to use for this example, there are many GCMs we can choose from. We're going to look at GFDL CM3. And the period we're interested in is going to be monthly data. So we're going to look at monthly data of GFDL CMIP3 air temperature. And in this case, we're going to have it bring back historical data, which includes from, I believe, 2050 up to 2005, 2006. And then we're going to include the future scenario data going out to 2100 using two different climate scenarios, RCP 4.5 and RCP 8.5. We'll not go into details of what they mean, but if you hover over the information buttons when you're using the tool, it'll break out roughly what those mean. And then you can choose your aggregation type. It can be max, mean, median, min, sum. And this is aggregating all the cells underneath, in this case, those polygons. And we want the output saved to a table. If I run this, it's going to take a few seconds. And what it's doing right now is it's actually making API calls or application programming interface calls to a URL address over at UC Berkeley. It's making the request, pulling that data back, and then it's going to store it inside of a file geodatabase on your computer. And it takes a few seconds, depending on the speed of your system. So now if we look at this, what the table is going to look like, I could open it here on the right, but I'll just look at the Jupyter Notebook or the ArcGIS Notebook. It's going to have the name, so Desert Research Extension Center, the date. So in this case, it's monthly. So here's January 1st, 1950. It's air temperature. Here's the climate model. It's a historic scenario, monthly data, mean. Here's a description of the entire thing that we just highlighted here. And then here's the value or the mean value and the units, in this case, C. So you can see that you have all that input. You have 5,856 records. So you have a monthly record for the last 150 years, essentially, for 2 RECs, Research Extension Centers. Does that make sense? Monthly data, I believe so. Then what are we going to do with that? We have the data now. It's in a file geodatabase. So let's graph it. Let's see what it really looks like. So we're going to go in here. We're going to right click. We're going to go to the CalAdapt Python toolbox. We're going to say chart data. And we're going to choose the output table. The output table in this case that we outputted from the previous tool was get data API. We're going to choose the date field. In this case, it's date time. We're going to choose the category field to map, which is the categorical field to graph, which is name. And then the value field is just called value. If I run this, it's going to create a chart. You can see it down here. It doesn't always open it by default, but if you open it by clicking on it, you're going to see this chart. And it doesn't look anything like this chart initially, right? So you have many peaks and troughs. You see every month's worth of data. So if we want to make it a little bit cleaner and easier to see what the trends are, we're going to go over here to the chart properties. So date time is still date time. We're going to aggregate it. We're going to say, give me the mean, but the mean over what time period? We're going to say the mean over, in this case, 10 years, because this is 150 years worth of data. So now I've got every 10 years what's going on. But remember, I said that this is data from the extreme Northern California and extreme Southern California. So let's split that. And let's see if we can get it to show desert rec and mountain rec and intermountain rec. And you can see the difference between those in terms of mean temperature. So if we go back to the chart properties, we're going to say split by, which is optional. And we're going to split it by names. And now you can see the mean temperature at both desert and intermountain over the next 150 years. So now if we go back to the history, we can see exactly what we did. We got the data from the API, and then we charted the data from the API. And I can go in now, and once again, I'm going to load the different tools and modules I'm going to need in packages, like pandas, NumPy, the same things as before. The difference is, though, now I'm going in and I'm going to tell it to use this custom Python toolbox. And that's what we have here. This is that custom toolbox. So it's going to find the location, and it's going to import that toolbox, and it's going to import it as CalAdapt. Then in the same location, there's a helper application called CalAdapt lib, which we're giving an alias of cal, and we're importing that. And then we're basically telling it what features to use, and they're going to come from the default geodatabase. And if I looked at the default geodatabase, which we haven't looked at yet, you're going to see results of what we've done today. You'll also see select recs and recs. So I'm saying use select recs, just like we did in the examples using the geoprocessing tools. And then I'm going to use the CalAdapt get data API that I ran using the tools up above. I want to point something out though. When you're using a custom toolbox, there's something you have to change. So if I say copy command and I bring it over here, it's going to stack all the different variables. But one thing that I did not, this is relatively new, is first stacking this. But what you'll see here is when I run the tool, one second. Oh, okay. So it's going to go in, it's going to import the tool because that's what the tool is doing itself. But then there are these two dots. And what I have found is if you run this just this way using a custom toolbox, it's going to error because it doesn't know what to do with that. But if you put in there CalAdapt, which is how we defined it up above, or was that right here? We define it as CalAdapt. If you substitute instead of just period, you actually put in CalAdapt inside there like this, then it works fine. So that's something to note. But if I run this now, it's going to do that exact same function. It's making a call, and you can see it in the history. It's going to go out, call for the same data, and it's going to drop it over here into the standalone tables. And it's going to take a few seconds, just like it did before. So it has completed. And what you're going to now see, the last one was called Get Data API. This one's called Get Data API Single. And I'm going to hit save just so I don't lose anything. It's called single for a reason. And the reason is using the ArcGIS geoprocessing tasks, you can't make numerous calls using a tool in a toolbox because it wants to always overwrite your values. So if I was to go in there and tell it to pull back different climate models and the historic data and the different GCMs, like I did, like the scenarios, it would overwrite it every time. So by using Python, though, I can get around that, and that's what we're going to do next. But first, let's talk about the charting piece. So once again, you can right-click on here and say copy Python code. You can paste that here, and you're going to see you have to replace the CalAdapt piece again. But it'll produce the same chart. If I run this, it did it. You can see it added the chart. And once again, it's going to be super busy. So I'm going to go in and aggregate it in the exact same fashion. I'm going to say aggregate, give me the mean. I'm going to go in and say split by name. And I'm going to go in and aggregate or bin it every 10 years. And it's going to looks exactly the same as the previous one. Right? So that's nice. You know, you can mimic the exact same functions and it works. But now let's take, let me see here. Get up to where we are. Okay. So this kind of highlights what we'd have to do. So let's say we wanted to combine together two GCMs for the same area. You'd have to run those tools twice, save them in different data sets, combine them back together, and it would be a little bit painful. It would take longer than it should. And what if you wanted to pull back all the GCMs for 10 different sites? It would become really a lot of work to do it. That's where scripting really comes in. So now we're going to really use some of the helper functions that are built in to make sure your resources are up to date and stuff like this. The minute you do the tool, part of these things are already ran. So like this is just going to make sure the resource list from CalAdapt's up to date because they are constantly adding new resources and building new things for us to work with. So by running this script, it always has the most recent list. But now using the API, we also need to have the geometries need to be split apart, and I described that earlier. where if you send one set of all the geometry at one, it's going to treat all the geometry at once. It's going to treat it as one thing instead of the individual slices. So we're going to turn these spatial data into something known as well-known text format, which is going to make web accessible spatial data that we can pass over the internet to the API. We're going to do that right here. And what you're going to see is it's indeed going to create the same features, but now it's going to be, if we zoom to it or zoom to one of them here, it should be here. Yeah, so this is the well-known text format. It's going to look exactly the same as the select recs, which is good because it should look the same. And it keeps sending me back for some reason. So we created the well-known text. And if you want to know more about it, you can see I've got the help piece built in, so it tells you what it's expecting. And now if you want to know what resources are available and not use the toolbox, you can actually go in and ask it different questions. So you can say, I'm interested in air temperature, GCM of MIROC 5, period of monthly period in RCP 45. If I run that, what's going to happen is it's going to go and query the data set, query the data, and come back and say, essentially, here are the different resources you could use, and then you can use that in a tool. And I'll let it show us that by uncommenting this line. So by passing in the variables I'm interested in, so the variable of temperature, this GCM, this month, and this scenario, it's going to tell me that there are 3 resources that I have available that I could use. These are historical, RCP 45, and RCP 85. And it's because, you see here, in this bottom example, I didn't tell it RCP 45, so it gave back each one of the options for those variables. Now this piece is going to actually be used with the API call, so it pulls back everything we're interested in. So here I'm going to say, in this next line, I'm calling out to the API and I'm saying, give me the data back, which is return data. The statistic is going to be a mean. And I want to use the well-known text geometry that we just created. And it's going to pull back the information up here from the CalAdapt file name, which includes, in this case, it just includes this, the temperature air monthly MIROC 5 RCP 45 data. So if I run that, what it's going to do, it's going to do exactly what it just described. It's going to make that API call. It's going to pull the data back and it's going to store it. And it's going to store it inside of, you see, where does it store it? Stores it in results. So you can't see it yet because we haven't saved it. It's in memory. So this is what comes back from the API. It's not the easiest to read. It's not the prettiest. And that's why we actually go in and we push those data that we got back from the API into a table. So here we're going to create a table using the create table helper application. Going to add it into a database, and it's going to be called get data API 1. So this is the first time, so we can discern it from the previous. And one thing that we're also going to do is this function creates all the parameters it needs to chart those data and use it in a chart function. So if I go in here and I run this, and I'll have it show us those parameters by uncommenting that line. It's going to go out, it's going to take the results that we just created. It's going to store them in a workspace, and that workspace is going to be get data API 1. And here are the chart parameters that we are going to pass to the cal create chart. So it knows that the field is date time. What we want to use for names or for splitting is climate description, what value we want to use, and then, and then the other variable we're going to need for charting, the table itself. So if I go in now and I create the chart by using the create chart, and notice I'm using the help, it'll tell us what the parameters it's looking for are. So once again, if I look at the help, it says the date field, climate description field, climate field, and table name. So I ran that, and now we have a chart under Get Data API 1, very similar to what we did earlier. Here it is. Here's the data. We're going to go in and aggregate it again. We're going to say mean. And this is just his future data for RCP 45. So from 2006 to 2100. I don't believe we're pulling in any other recs, so name doesn't matter. And we're going to change this to be every 10 years again. So there it is. So now we were able to make those calls all programmatically, not using a geoprocessing toolbox. So that's the first thing. But now let's go in and let's combine all those pieces together. So we've learned how to use the tool, the Python toolbox, or the Python application, the Python helper application above to make the same calls to the API. This time, what we're going to do is we're going to do those things again. We're going to use the select recs. We're going to save the data into a data set called multiple. Instead of just doing one global climate model, we're going to use two. We're going to do GFDL CMIP 3 and MIROC 5. We're going to do it for 3 different scenarios: historical, RCP 45, RCP 85. Variables are going to be temperature, air temperature, monthly, and it's going to be mean. So we could very easily have a list of different variables, and we could do temperature, we could do precipitation, we could do a bunch of different things, and it would just append all these to that data set. We're going to have it do the same WK well-known text shapefile conversion or shape conversion. We're going to go in, set the variables of where we want that table saved. And then we are going to go in, we're going to get the resources, generate the results, and create the chart, all within this one statement. This is an example of what Esri said, don't do in a cell with too much information. I kind of broke that little rule here. But if I run this, what's going to happen is it's going to go out and make those calls. It's going to do the call for historic, the call for RCP 45, the call for RCP 85, for each one of the global climate models, as well as each research extension center. So it's going to go through and do all those combinations. And it's going to take a few seconds. And if we want to watch it, we should be able to, I'm trying to think, does it let us? It may not show it here in the history because it's all happening on Python, not using Jupyter, not using the ArcPy and the toolbox itself. You'll know it's done when the asterisk goes away on the cell. The asterisk is gone and the chart is created. And we have a ton of data in here. So we have, you can see all the different variations. So historic, the different sites, the different climate models. So at this point, we can go in and we can do the same aggregation. So we're going to say mean. The split is going to be the description. It's the only way to really pull all those different pieces apart. And we're going to make it so that it's every 10 years again. So here you can see, here's desert, here's Intermountain. You can see historically how the two climate models, the historic climate models differ, sort of. Same thing with the future scenarios. But it's not the cleanest chart. You know, you have, ideally you would have the historic data automatically flowing into the different scenarios for each one. It wouldn't be different colors. It would be easy to discern the differences. So what we're going to do is we're going to take that same functionality we just used, but now we're going to go in and we're going to use pandas to do the very similar thing. Going to create a chart that's going to be easier to see and interpret. So I'm going to close that down. Close this one down. Make sure I hit save. And now if I scroll down, I don't know why it keeps resetting that. So here's that chart. But now what if we want to generate a nicer looking chart? So we're going to use pandas again. We're going to save those data that we just had, that we just generated. And we saved it up here into something called table. That's the path to that data set. So we are going to open that data set, that table in the file geodatabase into a data frame by using the command here. We are going to convert the data from Celsius to Fahrenheit. We're going to change the units from C to rename it F for Fahrenheit. We are then going to sort the data by value and see what that looks like. So there it is. We now have all the data. I don't have the shape of the data in terms of how many rows, but quite a few. And you can see the values are now in Fahrenheit. The units are Fahrenheit, and we're ready to really plot those. So the first thing we're going to do is, because the previous plot we sampled the data, or we basically sampled it, and in that case I think we used min or we used mean. Here we're going to do max, so it's going to be slightly different, but we're going to resample the data every 10 years. And that's what the A stands for. So it's going to be 10 years, 10, A for annual, and it's going to be the start. So the beginning of it's basically, when we summarize it, it's going to be to the beginning of that 10-year period is how it's going to report out. And we're going to report based on date time, and we're going to take the max. And then we're going to drop a couple additional fields, columns that we don't need. When we do that, we have a new data set. It's sorted by, it is going to be sorted by, basically it's going to be sorted by GCM and name. And the data set's ready to be plotted. We don't have to do a crosstab or a pivot table like we did earlier, because that data is not in that format. So we're going to create a new plot. We're going to label it. We have labeling. We have the group by. It's going to be SDF2, which is the spatial data frame. The group by we're doing is GCM and name. So GCM is the global climate model. The name is the name of the research extension center. And then, you know, what we're going to plot it by. So the X is going to be date time. Y is going to be value. And then we have the labels. And then we hear the title for the axes and the chart overall. And then where we want the legend. Pretty straightforward. And if we hit run, here's the chart we see. So unlike earlier, where we had all these other lines, all these different colors, all these different descriptions, where it was like, what are we really looking at? Now it's much cleaner. So what we see is, we see here, we got Intermountain, Muroc 5, Muroc, this is actually Muroc 5 for desert. This is GFDL for desert and what it looks like. And then down below, we see GFDL for Intermountain and Muroc 5 for Intermountain, going back to 1950 all the way to 2100. So really easy way to go in and really look at your data. I would say the hardest part of this piece is understanding the plot function and knowing what to put in. And once again, the internet's your friend. People are using these tools because they're open tools, and you'll be able to find out the different ways to plots and how to use those plots. So I only have a minute or two. I just want to quickly, and I'm not going to overwhelm you. Number 4 is the one that I knew I was not going to get to today, but I want you all to at least have the option to go through it. The big thing is, this is using the CalAdapt Python toolbox to pull back netcdf data. So I'm just going to load the functions. Don't worry about the warnings. And then I'm going to go down, and I just want to show you all. I've already pre-calculated this, so I should be able to just show you the underlying data. That. Generate, that's a custom function. Here's all the different variables. And I'm not going to do this step because it's already done. I'm just going to load it. So what this does is it basically brings data back from the CalAdapt API, just for your knowledge. It stores it on your computer as a series of multidimensional raster data sets called netcdf. You pass in a latitude and longitude of the area you're interested in. It pulls out a section of data along a time series. and then calculates further information, in this case, growing degree days, cumulatively over the year, and then stores it back out as growing degree days, and that's CDF data. And then you're able to then graph that data and look at it. So here I've already done that, but what you can see is I passed in a latitude and longitude. It queries the data, and this is what the growing degree days look like for a 2-year period. You can see how it increases through the year, resets at the beginning of the water year, and then does it again for the next. With this tool, you can then go in and tell it to, so it does it, it shows that table. Go to the next piece. Then I go in and I'm going to resample. So I'm going to say go in and resample to monthly data instead of daily data. Here it is, looks exactly the same, but now it's monthly data. And the last piece, which I think is cool, is you can look at all the data as one piece, growing degree days, and you can take a slice of time within those 2 years and look at what growing degree days look like. And if I plot that, you actually get a raster representation, spatial data inside of a Jupyter notebook. This is rapid. I dumped this on you, but this is the advanced one. Have a look at it and just see what it can do. That's all I intended to show you on this specific piece. So we have gone through 1, 2, and 3 of the Jupyter notebooks in detail. If you have questions, please let me know. Feel free to work on number 4 and just have fun, see if it works, see if you understand what it's doing. And one thing I should point out is that ArcGIS has something called office hours. And you can see that on our website where we help answer questions. And I encourage anyone, if you hit a glitch on number 4, let me know, because I always want to improve this section and get this piece so it's working properly. This is probably the most intensive set of scripts that we could use inside of a training like this. So if there's an issue that comes up, please let me know. With that, I'll open it up for questions. Oh, thank you for putting in the, please look at the chat window. We have a survey of how we did. And Maggie also put in a link to our office hours.
And we'll follow up with you guys next week. So, you know, if those people have had to log off, they've told me, so they're not here to hear this, but we will follow up with you next week. And we will also send out an evaluation form, and we will send out links to the video when Sean gets it all processed, and the presentation and all that jazz. And we would also love to hear if you guys have successes in your work and you want to brag about it to us. We love that.
Absolutely. Thank you all for attending today. We appreciate it a lot.